Let's talk about 275 H index 2. So given an array of integer citations, where citation I is the number of citations a researcher receive for their ICE paper, and the citation is sorted in ascending order. So return the researcher's H index. So what is the H index? The H index defines as the maximum value of H such that a given researcher has published at least H papers that has been cited at least H times. So that means let's look at this. What does this mean? At least H papers cited H times. So for example, example one, right? So there are 3 papers being cited at least 3 times because 3, 5, 6 are all greater equal to 3. And also there are 3 papers, right? So we need so this is H index is 3, right? But we'll say it's more than 2, right? Because 2, there are, of course, 2. We'll say 3 also satisfies the condition, but for 4, right? 4 papers, this one only cited 1 times, right? So the H index is already the maximum, right? So we are looking for the maximum. So the question give us actually ask, write the algorithm to run in logarithmic time. So this give us some kind of hint that is for logarithmic, it may have some method like binary search, right? And also it say that it has been sorted, right, or in ascending order. So if we give this hint, what we are searching for, right? So we know it's already been sorted. So we know the H index itself is a max value. So one thing is that we binary search this kind of H index values, right? So, but this one looks is very not intuitive. So the thing is that we are look at which data has monotonic feature, right? So the actual index, because the paper or citations already been sorted in an ascending order. So we are actually looking for this kind of index. And we want is that this kind of index at this index, C index, the number greater than the papers, right? The papers, what are the papers? The paper number is n minus index, right? So we are trying to look actually, we'll see that the H index is the index we find for this kind of situation. The C index greater equal to n minus index, right? So that is we are looking for the smallest this kind of index, and the H index will be the maximum of n this kind of index, which is smaller, equal to this C index, right? So the question is trying to convert to looking for the smallest index, or we are looking for the first index in this sorted citation array, which has C index greater equal to n minus index. Okay, so this is what we are searching for. So let's write binary search because citations sorted, right? Because this array is sorted. So we are binary search the first index, which has n minus index. This is the paper number greater equal to no, it's smaller equal to, right? So we can also write this citations index greater equal to this, right? So if we find this index, the H index, right? So the H index will be the first this kind of index what we find from the binary search n minus this kind of binary search first index, right? So if we know if we know the transitions of this kind of question, right, we can write binary search for this very easily. So let's write code for this. So how int n equals citations dot length, and so let's search the first index. So we are going to have a start equals 0 and equals n minus 1 as such um, in this array, the index. So we'll say while this kind of start plus 1 smaller than n, we're going to have int mid equals start plus n minus start divided by 2. So I'll say if this kind of citations mid is already greater equal to this kind of n minus mid, right? So that means we can still get a smaller because we want to find the first, right? So the first may be on its left. So we are search on its left part. We'll have n equals to mid. Then we'll have else. We'll have search on its right part. Start equals mid, right? So because we are looking for the first index, so we are when we go out of this while loop, start is one index be ahead of end. So we are trying to see if citations start is greater or equal to n minus start, right? So in this case, this index is the smallest index we find, and the H index is returned n minus start. And can we directly return n minus n? Actually, we cannot, right? Because here n will always have value, right? So that means the citations, the H index we get is always a positive number, right? If we only look at start and end. So we also need this, that if this kind of end is greater than n minus n, will return n minus n. Otherwise, we return 0. So there is a corner case, right? So we'll say there are, this will be the corner case. So we'll say there are 0 papers and greater equal to greater equal to 0, right? Or we'll say this one, 1, right? Let's look at this one. Well, I think we can look at this kind of corner case. Let's look at run this. you see, for this kind of zero, right? It will return zero. And you see this one means there are zero papers being cited at least zero times. So it returns zero, right? We cannot say one at least one times. There is no paper returns one times, right? So this will return zero. But the thing that because the start and end they are in the range n0 to n-1. So if we don't have so we need to judge both start and end because these two they are both positive value, right? But for this case, you'll see there are zero papers being cited max zero times, right? So this is return zero. So doing like this, the time complexity will be logged because it's already been sorted. Python code will be very similar, right? And let's write Python code. We'll have n equals length citations, and we're going to have start n equals 0 and n-1, right? Then we'll say while start plus 1 smaller than n, we'll have mid equals we can have start plus and divided by 2, right? Because for Python we don't need to worry about the overflow. We can just write don't need to write start plus and minus start. So I'll say if citations mid is greater equal to n minus mid, right? Then that means because we are looking for the smallest index which satisfies this kind of condition, right? So that means the index we should still search on its left. Then we'll have n equals mid, right? And else we'll have start equals mid. So when we're jumping out of the while loop, we'll check if citations start is greater equal to n minus start, and we return n minus start. And if citations n greater equal to n minus n, we return n minus n, and otherwise return 0.